Welcome to those of you who got on to the 2023 New Jersey Envirothon virtual training workshop. My name is Lily Mell, and I've been coordinating this event on behalf of the New Jersey Association of Conservation Districts for the past 4 years. Our incredible host district this year is the Freehold Soil Conservation District, and Holly Reynolds, who's a longtime New Jersey Envirothon champion, supporter, and an amazing resource, has thankfully been co-coordinating with me. As many of you are aware, for the past few years, we've had to turn our hands-on event into a virtual event, and we couldn't have done it without Chris Edwards, who's our technical wizard and is hopefully working his magic and getting some of our advisors on. The Envirothon is supported by a partnership of organizations known as the New Jersey Conservation Partnership, which includes the New Jersey Association of Conservation Districts, New Jersey Department of Environmental Protection, Rutgers, and the U.S. Department of Agriculture, Natural Resources Conservation Service, and the New Jersey Department of Agriculture. And you usually hear all of those as lots of initials: NJACD, NRCS, USDA, DEP, but that's the full names. I want to sincerely thank all of the presenters, advisors, and students for participating today as we prepare for our May 20th event. We're thrilled that the Envirothon will be in person, but we felt taking advantage of virtual platforms would make it more convenient for all the participants. We are recording this, so any teams who can't attend will have access. As New Jersey makes statewide action plans to deal with rising temperatures, the environment has emerged as a top concern for the Garden State. So it's fitting this year's current issue is adapting to a changing climate. We hope you all appreciate the chance to hear from and interact with professionals from a variety of fields and organizations in environmental science and protection. I'll introduce each presenter before their portion of the program. So without further ado, we will begin with our aquatic stations reps. Today's aquatic presenters are watershed ambassadors Michelle Hatfield, Sarah Falk, Sue Livingston, and Cameron Shapiro. The Watershed Ambassadors program, which has been around in New Jersey for over 20 years, is administered by the New Jersey DEP. AmeriCorps members are assigned to each of New Jersey's 20 watersheds, and each ambassador is tasked with promoting watershed stewardship through education and community involvement, and they monitor stream health through visual and biological assessments. So I am going to mute and ask our watershed ambassadors to present for the aquatic station.
Okay, so we are the aquatic station for the 2023 Envirothon. Next slide. So we just want to do a quick overview of the different learning objectives that we're going to cover. We're not going to be going into, a whole lot of detail today on every single thing that's going to be on the tests, but we do cover the abiotic factors, biotic factors, aquatic environments, and water conservation and protection. And it's just a reminder to always check the Envirothon website and see the handouts and the resources that we put together online to kind of guide your studying. So next slide. So first, to start off, we're just going to talk about watersheds and how to delineate them, get a bit into topographic maps. So a watershed is an area of land where all the water drains into one source. So that could be a river, a lake, a stream, but they are defined by their topographic features, which basically just means hills, mountains, and valleys. And so based on that, when we delineate watersheds, we use something called topographic maps. And when I say delineate, it basically just means that we're defining the boundaries of the watershed. So where those topographic features are, because of gravity, and water moves from high to low elevation. So we can assume that that's why those topographic features are the boundaries. So on a topographic map, we have a couple of definitions. We have our contour lines, and we will be showing an example of a topographic map, so you can kind of see what I'm talking about. But we do have these contour lines. They each represent a level of elevation. And you might have seen these before. They're kind of like, they're not always perfect circles, but they're just kind of loop around, and they each indicate, like I said, an elevation. Our contour lines will never intersect. And as I said before, all the points along that single loop or that single contour line will always be the same elevation. And then as you move from different contour lines, the distance between them is called our contour interval. And then you can go to the next slide. So our horizontal distance between our contour lines will indicate our steepness. So in this example, you can kind of see that they aren't too close together. So this can indicate a relatively flat ground. And you can also determine that by, you can see that the contour intervals between all of our contour lines are about 2 each. So that would be something that would be relatively flat. Next slide. And just as a note, the water will never flow with the contour lines. It'll always be flowing perpendicular. And just like, you know, with gravity, it's always going to be flowing from a high elevation to lower elevation. So the water flow is always going to be downhill. Next slide. So here's a bit more of like a more detailed example of what I'm talking about with the topographic maps. So you can see here that we determine the water flow by looking at which way the topographic lines are pointing, because they make these V's that always point upstream. So in this example here, you can kind of see, you know, maybe 2 tributaries flowing into a central body of water. In this case, the upstream would be, if we were to say that this is a Y, the upstream portion would be at the very top of the Y, and it would be flowing downstream into the bottom and kind of converge. Next slide. So this is in really big detail. So this is kind of what you will see when you're actually looking at a topographic map. The X's on the map, those blue X's, kind of are our summits of hills. You can tell that because 1, they have the highest elevation, and 2, you can see that the contour lines are kind of getting steeper as you go up. It might indicate, you know, a very high summit or a hill. And that these areas where the blue X's are might be where we delineate our watershed, because they're the highest points topographically or in terms of elevation. And you can even see, unfortunately it's hard without a pointer, but you can kind of see where it says Sherman Brook between the top 2 X's. That's kind of like our watershed, where the water is flowing down in between those 2 points, and then flowing into the Glen Rock Reservoir. So this might be the Glen Rock watershed, depending on the other topographic features in the area. You can also see just how steep the mountains are based on the number of contour lines and the distance between them on those mountains. Whereas if you look in the Glen Rock Reservoir, if you can see down in kind of the lower right, where it's labeled the Glen Rock Reservoir, it's kind of more flatland, because you can see those contour lines are further apart and not as steep. And then next slide. Okay, now we're going to move on to groundwater.
Okay, so yes, so next we'll be talking about groundwater. So you should kind of be familiar with the groundwater lingo and also how it is monitored. So groundwater is subsurface water that fully saturates pores and spaces between soil and rocks. As for the distribution, there is 30 times more groundwater than surface water on Earth. And oftentimes groundwater is sort of hard to monitor. So GIS can actually be used to make models and make predictions through a computer. So some lingo to know is water table. So the water table is the level below the ground, which is saturated by water. Recharge. Recharge is when surface water moves into the groundwater. Be familiar with aquifers, which are bodies of rock that can let water pass through, and be familiar with the different types of those. Also, saturated and unsaturated zones. They're pretty self-explanatory. Unsaturated zones are zones that are not where the spaces of air are not filled with water, and saturated zones are where everything is filled up with water. And then saltwater intrusion, that can happen when an aquifer is depleted, and saltwater can actually rush in. Next slide. So next, we're going to be talking a little bit about invasive species, which are non-native or non-indigenous species that can negatively impact the diversity and abundance of native species. So this means that they have no natural predators here. So they really have nothing to keep their populations in check. Therefore, they kind of outcompete the native species. They also affect the stability of ecosystems, so like a food chain, and also commercial, agricultural, and recreational activities that humans use them for. Next slide. Okay, so they are intentionally and unintentionally spread, again, mostly by humans. They are spread through things like ballast water, boat holes. There are intentional introductions. There are like aquaria releases. And there are some other ways that they are spread. Definitely be familiar with those. They are also known as aquatic nuisance species. And we will kind of talk more about those on the next slide. Next slide. So these are just two examples of aquatic nuisance species in New Jersey. On the study guide, there is a full list of aquatic invasive species to know. So definitely be familiar with those. Definitely be able to identify those. On the left, that is rock snot. And then on the right, that is water chestnut. So just be familiar and be able to identify them through pictures and maybe some artifacts. Next slide.
All right, so we're going to talk a little bit about benthic macroinvertebrates next. So if we break down that giant word up there, benthic just means that they live on the bottom of the stream. Macro is they're large enough to see with the naked eye. Now, some of them might still be really, really small, but you still technically can see them with the naked eye. So we do say that they're macro. And then invertebrate is anything lacking a backbone. So this includes water bugs, but also things like crayfish and clams, which also fall into our invertebrate category. We use these as indicators of stream health or water quality. So if you have certain types of macros in a stream, it can kind of tell you if your water's pretty healthy, or it can tell you if your water's kind of polluted. And they also are kind of easy to identify if you have a key with you. So there's 3 different pollution sensitivities that these guys can fall under, and I included an example picture of each one. This is not a comprehensive list. On the website under biotic factors, there is a macroinvertebrate guide that kind of has a more comprehensive list of the kind of macros that we can find in New Jersey and the ones that we look at to tell us the quality of the water. So we have up here in the top left our pollution sensitive. This is a picture of a mayfly. If you find a mayfly in a stream, your stream is probably doing pretty good because these guys can't handle a lot of pollution, if any at all. And then right next to him, we have our pollution neutral. So this is a net spinning caddisfly, and he can handle a little bit pollution, but not a lot. And then down at the bottom, we have our blood red midge. This guy is pollution tolerant. So if you find a lot of these in a stream, it's probably not doing that great. But as long as you find one of our pollution sensitive, you know your stream has a chance or could be doing better. So this is a dichotomous key. Dichotomous keys are kind of used to help us identify these bugs. When they're really, really small, it can be hard to kind of differentiate them. So these are really helpful. So basically how we use these is you kind of start at the top and you'll have two paths that you could follow based on what your macro is looking like. So this one kind of starts with shells or no shells. So you would pick an option based on what you have in front of you and then follow it down. And then we have two different types of streams, rocky bottom streams and muddy bottom streams. I believe where we'll be would kind of be, I think muddy bottom. I'm not quite sure. But our muddy bottom streams are low velocity. So certain macros really like muddy bottom streams, and other ones that need maybe a little bit more dissolved oxygen don't kind of frequent those streams because of that low velocity, right? And then our rocky bottom streams have a more high velocity, lots of riffle areas in them. On the website, the Georgia's Adopt a Stream manual is very helpful in kind of differentiating these. There's lots of examples within there to kind of help you out and see what stream you're working with, and then kind of what macros like what.
We thank the watershed ambassadors for a wonderful presentation. We'll move on to forestry, and we will have Joe Bennett, who is a forester at the Forest Resource Education Center in Jackson. He is employed by the DEP. It's a wonderful, beautiful Pine Barrens Forest site, and he is also the Big and Heritage Tree Coordinator.
Okay, good morning, everyone. Can you hear me okay?
Yes.
Okay, good. All right, so I'm going to give you a brief tutorial on tree ID. Once again, my name is Joe Bennett, and I'm with the New Jersey Forest Service. I'm going to move into the first slide. How do we identify a tree? Well, there's a number of ways, and before I get into those ways, how do we identify one another? Well, you know, one person might have blue eyes, another person has blonde hair, and they have all these different characteristics. Well, trees have different characteristics which we can identify them by, and we're going to get into that now. So the first one would be leaves. We have trees that have regular leaves. They have different types of shapes and sizes, and then we have evergreen trees that have needles, which are long and pointy, and leaves are very helpful in identifying a tree. The next one would be the trunk. The bark on trees, some bark may be similar, but it's really not the same. Bark is some bark exfoliates, which means it peels off. Some is smooth, some has ridges and plates. So when we look at the trunk and the bark, that is a good way to identify a tree. The branches. When we think of branches, there are certain trees that have like downward trending branches. They kind of hang down, and that helps us to identify the tree by looking at their branches and the way they attach to the tree and hang off the tree. And once again, I said kind of with the truck, we have bark. We have all different types of bark, which helps us to identify the tree, not just, you know, by its texture, but also color of bark and so forth. Buds. Buds, there's valvate buds, which are just like two halves, and then there's like imbricate buds, which are lots of scales and stuff. So that if we look at the buds, we can identify trees by their buds. And then we have the roots. Some trees, their rooting structure will come up out of the ground, like bald cypress. They have knees and stuff. So that's a way to identify that particular tree. When you see that sticking up, it's a dead giveaway that it's a bald cypress. Now there's two that I didn't mention but one would be form, and we kind of did that when we talked about the branches and downward trending, but also like there's also fruits and there's acorns and seed that also help us to identify the tree. So these are very important characteristics right here, which help us to identify all the parts of a tree can be used to identify the tree. So then here's a tool that we can use. We have tree identification keys, and we have one for conifer and one for broadleaf. So we have an example here in the lower left-hand corner, and I think if we look at it, we can tell that those are needles, right? We have needles there. So what do we do when we have needles? We use the conifer key, and we start at number 1 where it says needles in a bundle or groups of 2, or groups, and then that would say go to number 2. So we have needles right here that are in a bundle or in groups, so we go to number 2. So needles, so we have needles in clusters of more than 5. Well, when we count, we have 1, 2, 3, 4, 5, but we don't have more than 5. So we would go needles 2 to 5 per bundle, pine species C, A through C. So when we go through A through C, we look at the first one. It says we have 5 needles per bundle, or they call it bundle. You could also call it vasicle, which starts with an F, F-A-S-C-I-L-E. And so we have 5 needles per bundle, and then it tells us that's a white pine or Pinus strobus. And so here's a picture of what a white pine cone would be, and 5 needles per vasicle. Whenever you see 5 needles per vasicle, that's a dead giveaway that it's a white pine. And you would just, if you had different types of needles, you would just continue to follow down these instructions. These are good tools when you're first starting out and first identifying trees, to go step by step by step. But as you get skilled in identifying trees, you just really recognize the characteristics, and you really don't need this once you start to get advanced. And this is included on your training page. Okay, so the next key would be for like a broadleaf. So you would start off the same way that we did with the conifer key. Do we have opposite branching? Here's our example here in the lower left-hand corner again. Do we have opposite branching? Do we have alternate branching? Well, I can tell you right here that I know that this is an oak species. So we don't have opposite branching. We have alternate branching. So it's telling us to go to number 4. So you go down to number 4. And the first one that says compound leaves. Is that a compound leaf? No, it's a simple leaf. So we go to the next number 4. Simple leaves. It says go down to 8. 8 leaves not lobed. Go to 9, or 8 leaves lobed. We know these are lobes because every one of these indentations on this leaf is a lobe. So it says leaves lobed, oak species C, A through F. Okay, so the first one, choice A, says rounded lobes, 5 to 9 deep lobes. If I count this, I have 1, 2, 3, 4, 5, 6, 7, 8, just about 8 lobes. And it says 5 to 9 deep, even lobes and sinuses, leaves hairless. And so that's a white oak, Quercus alba. And that's how we figured out Quercus alba. And you can do that same type of process for other trees, that for different types of leaves that you might have come across, or trees. And this is also on your training page. And this is just part 2. If you needed to continue, this is part 2 of the broadleaf key. You needed to go down further to find and identify other leaves. You have this part of the key as well. As just broadleaf is a 2-page key, and the conifer is a 1-page key. Okay, so now we're getting into tree identification terms. The first term that we have is conifer, and I think most people would recognize when they, see a conifer tree, or a tree that they put up as their live Christmas tree at home, that it has the needles, and they're kind of, like I said, kind of like short and long and pointed. And another way to refer to conifers is evergreen. When we identified the white pine, we talked about it having a bundle. And that bundle is also known as a vasicle, and that is in this little picture with the 5 needles. Like I said, here it again, 1, 2, 3, 4, 5. What is that? You can say to yourself, everybody should know by now what? That's a white pine or Pinus strobus. Then we get into the term scaly. That just means all these buds, all these different scale buds. That's another way to identify the tree. They just have lots of scales and lots of buds, or imbricate is a fancy way of saying scaly. Then we have broadleaf, which is a tree that has broad leaves rather than needles. And this is also just referred to as our deciduous trees. These are our trees that will have their leaves that fall off in the fall time. We pretty much, now they're all getting their leaves right now in the spring. Those are all pretty much all your broadleaf trees. So just, that's an important term to remember. Alternate branching, that just refers to like the branches, kind of go up in a step pattern, or a branching pattern where side branches and leaves do not grow directly. And then you have opposite branching. We're going to talk about that more in a future slide, but that's where the branching basically happens opposite from each other. So one side comes out of the stem and it comes out the other side, and they're equidistant from each other. Okay, so now we're going to get into leaf types. And this is something that you can study on your own. We don't have to get into it in detail, but you have ovate leaves, you have elliptical leaves, lanceolate leaves, and the descriptions are all here for all of these. You have ovate, cordate, which means they're heart-shaped. One of my favorite trees is a redbud tree that has the beautiful pink blossoms that are coming out right now. That's cordate-shaped. You have oblong, auriculate, oblanceolate, and needles. So just something to study at your leisure. And then on page 2, we have palmate, which means kind of like similar to like when you open up your open palm. It's similar to that type of shape. You have scale-like, you have simple leaves. You have bipinnately lobed, all-like, pinnately compound leaf, which has leaflets arranged on both sides of the rachis or axis bracket. And then you have bipinnately compound. Twice pinnate, the primary leaflets are divided into secondary leaves, also written two pinnate. Okay, so now it's my understanding that all of you have your Trees of New Jersey booklets, and these are going to be very helpful tools when you go out and identify trees and you start to study and practice for your Envirothon test. On page 4, you're going to find out the types of the leaves of trees. On page 5, it's going to give you types of fruits and flower parts. We talked about that in the second slide. Tree profiles are going to be from page 9 to 104. That's where you're going to get more of the in-depth description of each tree and a picture of it. And then you're going to have the invasive tree species on page 105. All right, so moving on. Now here's a tree. If you can all kind of take time to look at it and identify it. You have bark, you have a fruit, you have leaves, and try to identify it. I'll give you like a few seconds to think of what you think, and then when I say what it is, then you can kind of see whether you were right or wrong. All right, so I'm going to give you a few seconds. Okay, and this is a persimmon tree, fruit tree. So how many of you got that right or wrong? If you got it right, you can kind of pat yourself on the back. And if you didn't, maybe you just need to put in a little more work. Now we have another tree, and this is an important tree to know. I'm just going to point that this would be something that is important for you to know. You have the trunk and the bark. It's kind of like rigid and hard. And then you have the tree. It looks to be about, I don't know, this one looks to be about 45 feet tall. And it's definitely in fall season because it's at the fall colors. And the branches are coming in at 45-degree angles, and you have the simple leaf. What do you think that this is? Well, here's another picture. I'll let you kind of look at it and think about what you think this tree might be. And now I'm going to give you the answer. Black gum. That's important to remember that. There's a lot of these trees all over throughout New Jersey, and this tree is a black gum. And like I said before, an important feature of this tree is it has the 45-degree angle branching that go to the stem. Okay, so here's a broader description of the black gum. It features straight trunk with unique bark that forms deep fissures within the age. We saw that on the previous slide. The tree is typically 9 to 15 meters or 30 to 50 feet or more in height. The leaves are simple, glossy leaves, and entire, slightly toothed or wavy, and usually elliptical in shape. Here's another tree. It has trunk sprouts. It's kind of get an idea of the height of the trunk or the tree right here. And then you have a smaller type cone with the little prickles on it and the needles. Does anyone have an idea of what this tree might be? Okay, I'm going to give you the name. It's a pitch pine, and its scientific name is Pinus rigida. It's small to medium, 40 to 70 feet tall. 3 needles per vasicle, right? Or bundle. Before it was referring to bundle or vasicle, both the same thing. 3 needles per vasicle. Its uses are pulpwood, crating, and fuel. And it's included in your NJ tree field guide. All right. So we're going to move on to the next slide. And here we have a few different components or parts of the tree to identify what the tree might be. And I think everyone should be able to get this by now because we've seen it a few times. But we're going to start with the needles, right? We have 1, 2, 3, 4, 5, right? And then we have our bundle here, our vasicle. So 5 needles per vasicle. That should be a dead giveaway to what type of tree this is. The cones, 4 to 9 inches long, and I'm sure many of you know what it is, and I'm going to tell you. It's white pine. Scientific name is Pinus strobus. 5 needles per vasicle. 50 to 80 feet tall, so they can get pretty tall, and they can get pretty big in circumference too, which means how big they are around on the trunk. And the uses are windows, doors, matches, boxes, patterns, as well as construction lumber. And if you were using your conifer key, the steps would be 2A, and that's how you would figure that out. This is also included in your NJ tree field guide. Okay, so now we have another tree here that we want to identify. We have some idea of the height, right, from the picture. And now we see these cones, which are 4 to 9 inches long. We have downward trending branches. We talked about form being a factor when we identify a tree, and we have these downward trending branches. This might be a difficult one because we didn't talk about it yet. And so if anyone gets it, fantastic, but I'm going to tell you what it is now. It's a Norway spruce. Its scientific name is Picea abies. 60 to 100 feet tall. The cones are 4 to 9 inches long, and needles are dark green in color, and half inch to an inch long, smooth, stiff, and pointed. Those are your needles. And this is also included in your NJ tree field guide. So you might want to be marking these off in your tree guide as we go along. Now, here's an important thing. How do we know which trees have opposite branching? And there's a little trick on how to do that, and that's mad horse, and that is maple, ash, dogwood, and horse chestnut. And all of these species have opposite branching. So that would include sugar maple, red maple, silver maple, white ash, black ash, flowering dogwood, American horse chestnut, and there's more. These are just a few examples that I've listed here. And then you can see in the upper right-hand corner, we have an example of opposite branching, and we have an example of alternate branching. So that gives you an idea. So you can see with opposite branching, they're right across from each other, and alternate branching is kind of like a more like a ladder type situation. And on the left, our example would be maple for opposite branching, or actually here on the left, oops, excuse me, I have to get back. On the lower right, we have maple, and then we have the branch that you can see below there where there's opposite branching. That's an actual example of a branch that has opposite branching, maple. And then we have an ash, which has opposite branching also. So those are two examples right there. Okay, then we have questions. The first question is, what do maple, ash, dogwood, and chestnut trees have in common? And I'll just give you a couple seconds to think about it. Okay, we just talked about it in the previous slide, so it would be choice B, right? They all have opposite branching. And then the second question I have for you is, which tree species has evolved survival adaptations in New Jersey's fire ecosystem? You have choice A, red cedar, B, eastern hemlock, C, pitch pine, or D, eastern white pine. And I'll just give you a couple seconds to think about that. Chime in your answers mentally. And the answer to that is choice C. And so without further ado, I would like to wish you all good luck on your Envirothon on May 20th. And that's all I have for you today.
Thank you, Joe. We're a little ahead, but we will move on to team presentation. We'll have Sheila Hall, who's a resource conservationist for Morris County Soil Conservation District and is another example of someone who's been a long time participant and champion of the Envirothon and this particular very important station. And Sheila's gonna talk a little bit about the team presentation station.
Thank you, and good morning, everyone. Welcome to the New Jersey Envirothon training, and I'm the coordinator for the team presentation portion of the Envirothon, which is a little different than all the other stations because you present in front of a panel of 5 judges, and you get a specific problem to solve and present on that relates to the current issue for this year's event, which is adapting to a changing climate. We are very fortunate to have someone from Rutgers to go over all the nuts and bolts of this very broad topic. His name is James Shop. I hope I have the last name pronounced correctly. And he's going to be coming on right after me. And I'm going to try to keep it brief. I just want to, go over the nuts and bolts of this station. And if anybody has any questions about how we conduct the team presentation, I am the one to ask. And also, hopefully my email and my contact information will be put up at on the Envirothon site. I know when the presentation problem goes out, we put that up so that if anybody has any questions about the problem itself, they can ask during the week of the Envirothon while the teams are preparing to present. So to start off with, the team presentation problem will be posted on the New Jersey Envirothon website first thing in the morning on Monday, May 15th, 2023. And that gives the teams time to prepare their note cards, go over how they're going to structure their presentation, what sort of visual aids they might incorporate into their presentation, etc. Teachers and advisors are not permitted to provide answers or solutions for the presentations. Of course, they can give the students space and answer non-specific questions, but they cannot help the students actually create the presentation. The Envirothon teams must prepare their presentations without assistance from their advisors. But that is to say, if the teams are uncertain about wording of the presentation, or anything of that nature, they have questions, the advisor can certainly relay questions to us, and then we can relay answers back to the team if that's necessary. Or the students are allowed to do that themselves, of course, as well. So, as you're preparing for your presentation, teams, keep in mind that you're allowed to bring up to 5 note cards, and they are 3x5 cards. No other format is permitted, and the note cards can be clipped together in order. And I've seen all different kinds of note cards through the years that I've been doing this. Very creative. I've seen little tiny writing on the note cards with lots of writing. And I've seen pictures, and I've seen just bullet points, everything you can imagine, but it has to be on a 3x5 card. You can use front, you can use back. They can be colored, but it's just 5 3x5 note cards, okay? When the students arrive to register for the Envirothon the morning of, they are to hand in these precious note cards to the people running the registration. And the reason why is that we don't want you to use those note cards to get hints at the other stations. So you need to hand your note cards in, and don't worry, you will get them returned to you when you arrive at the team presentation station. The first thing we will do is return the note cards to the teams that are presenting during their preparation time. So don't be nervous when you're handing in your note cards. We take very good care of them, and we'll give them back. At the event, when the students go through the rotation, there will be a team presentation station. It's usually 2 closed classrooms with judging panels in each classroom, so we don't interfere. I'm not sure how it's structured at this particular locations, but the important thing is that each presentation station doesn't, you can't overhear what the other students are presenting on. It has to be kind of soundproof. So the team will present in front of either judge panel A or judge panel B. And the reason why we have 2 judging panels set up is due to the fact that we have 17 teams going through the stations, and we have only a certain amount of time. I think it's 4 hours to go through the Envirothon. So we got to get you all through the stations in a timely manner, and we have 2 great panels of judges this year. And your team schedule during the Envirothon will, of course, include the team presentation station. That'll be part of your rotation. At each station, there will be 5 judges, and each team presents in front of a panel of 5 judges. There will also be myself and another person on site just to kind of keep everything flowing, instruct the students, and keep track of the scoring for the station. During the event, when the horn blows, 4 teams will arrive at the presentation station every half an hour. The team with a lower number at each station will go first. So if we have, say, 7, 8, 9, and 10 team, the teams with number 7 and 8 will go first. 9 and 10 will wait off to the side for 15 minutes. They get a little break, and 7 and 8 start doing their prep. You get 5 minutes of preparation time to kind of huddle with your team, work on your visual aids with your flip charts and your markers, get your note cards, and get your wits and courage about you to do your presentation. So then after the 5 minutes of preparation, you will be escorted into your presentation station A or B, and then you will have a time of 10 minutes to present in front of the judges. The judges will have a timer. One of the judges is going to be charged to be the timekeeper. When you do your presentation, we ask that you go in front of the judges and give them your team number. Don't give them the name of your school. You're going to be assigned a team number during the beginning of the Envirothon at the registration, and that's what you use throughout the event, and that's important. We want to keep anonymity. That keeps the level playing field. So you give your team number to the judges, and the judges make sure to write on their score sheet their judges' initials, so we know which judges are giving which scores in case there's any questions at the end. You have your note cards in hand during your presentation, and you will also get flip chart and markers. Those are the only items that you will be permitted to use for this 10-minute presentation. Questions may be asked up to one by each judge during the 10-minute presentation. So usually what I recommend to the students is plan for about a 9-minute presentation, maybe a little bit more, because you're always going to be asked questions by the judges. And a little hint for all the students, be aware of who are the sponsors for the New Jersey Envirothon. The judges like to know that the sponsors are credited, and it's possible that that's a question that may come up during the event. So just make sure you look at your Envirothon information and familiarize yourself with the sponsors for the event. After the presentation, the judges will have 5 minutes to compile scores, and then they give them to the proctor. Also, during that 5 minutes, we call up the next group of teams, the 2 that are waiting in the wings, to come on board and start preparing. We give them their note cards, flip charts, markers. They get that 5 minutes to prepare while the judges are tallying their scores. So there's a lot going on at this station, but we've got it really down to a science. So don't worry. And of course, if you have any questions, feel free to ask them at any time. And then finally, the proctor takes the score sheets from the judges and tallies them up. Number 1, we make sure that the judges' score sheets, they filled in everything on the score sheets and all the addition and everything is done correctly. We do the math for them. And then since there's 5 judges, we follow the format as done at the National Envirothon, where the top score and the bottom score are discounted, and the 3 middle scores are averaged together. And that's how we come up with the presentation score for each team. So that's all I have. I'm going to turn this over to James now, and he's going to talk about adapting to the changing climate. He has a very interesting presentation. And then at the end, if you have any questions, we'll be here to answer them. Thank you very much.
Awesome. Thank you, Sheila. Can you hear me?
Yes.
Awesome. All right. I'm going to share my presentation. All right. Are we good?
We can see it. Yeah.
Awesome. Cool. So today I'll be discussing New Jersey's climate. So we're going to be looking at past climate trends and future climate projections, and maybe how we can adapt to them and the impacts they may have. So a little bit about me. I'm Dr. James Shope. I'm with the Climate Change Resource Center out of Rutgers, as well as the Department of Environmental Sciences at Rutgers. So I always want to start with just an overview of climate change. So let me move this out of the way. There we go. So climate change is caused primarily by the combustion of fossil fuels, coal, petroleum, natural gas, that emit greenhouse gases into the atmosphere. So there's a number of different greenhouse gases. So we have carbon dioxide, we have CH4, which is methane, we have nitrous oxides. There's a number of different ones, but carbon dioxide is the largest one. So that's why we focus on it so much in our discussion. So it's responsible for the greatest share of the observed amount of climate change that we've had. Now, if we look at the concentration of carbon dioxide in the atmosphere, we have this graphic down here. So we measure carbon dioxide in the atmosphere in parts per million, in terms of parts of carbon dioxide per million particles. And we have measurements at Mauna Loa Observatory in Hawaii ranging back to the 1950s. So the red line actually represents monthly measurements, then the black line is just a trend through that. And you can see that the amount of carbon dioxide in the atmosphere has been increasing since the early to mid 50s. And since this curve is bent upwards a little bit, it also means that the rate at which we're putting carbon dioxide in the atmosphere has also been increasing. So it's increasing at a faster rate. There we go. And the direct result of those increased greenhouse gases is increased temperatures on Earth. So global temperatures have risen by about 2 degrees Fahrenheit since 1900. So that's what this graphic down here shows. So it's showing a temperature anomaly or temperature difference in degrees Fahrenheit relative to the mean of 1900 to 2000. So that's why we have some positive and negative numbers here. But basically 0 is the average from 1900 to 2000. The black line represents the annual measurements of temperature. And then the red line is just a smooth trend through that so we can see what's going on. So temperatures have been increasing since the early 1900s. And since about 1970, late 1960s, around 1970, our temperatures have been increasing at a much faster rate. So we have our greenhouse gases that are increasing and increasing more rapidly. We have our temperatures that have been increasing, and they're starting to increase more rapidly as well. So that's kind of the broad overview of global climate that we need to know, just so that we can start thinking about New Jersey's climate in particular. So New Jersey's temperatures have been following a similar pattern to the global climate. So this graphic here is a little busy, but I'm going to walk you through it. We have temperature change here on the y-axis relative to this black line, this horizontal black line. And that represents the average from 1901 to 1960. So basically the first half of the 1900s. The orange line represents our observed temperatures here in New Jersey. And broadly, they've been following the similar trend. So our temperatures in New Jersey have increased as well. And they've increased by about 4 degrees Fahrenheit. So since 1900, so about twice the global average. The gray area represents using computer models to recreate the past. And so you don't expect it to one-for-one recreate this curve, but you expect it to be in the same ballpark, and that's what this shows. And so we take those computer models and put in what we think may be future emissions of greenhouse gases and other climate change factors to create what we consider or what we call emission scenarios. So here in green, we have a world where we have somewhat lower greenhouse gas emissions, and in red, we have a world where we have somewhat higher greenhouse gas emissions. And those models provide projections of what our temperatures may be by certain years. So by 2100, for this lower emissions here, it's about 2 to 8 degrees warmer on average. And then higher emissions, about 8 to 14. So a few takeaways from this graphic. One, even if we follow lower emissions, we're still going to have a number of very warm years in New Jersey moving forward. So that's worrisome in some ways. But what's really empowering about this graphic is we can decide our path based on our emissions globally. So based on our actions in our homes, our actions within our state, and the actions of our nation, we can lower our greenhouse gas emissions and be along a more sustainable trajectory into the future. And one of the other things that's very nice is we're actively already following this lower emissions pathway, and we're at the lower end of that based on today's policies. Now, we still need those policies to continue working over the long term, but we're moving towards a correct direction. Now, let's think about the impacts of those temperatures. So with higher greenhouse gas emissions, that red pathway that we saw earlier, by about the middle of the 21st century, so in about 30 years, we expect about 70% of our summers to be warmer than any before 2006. And by the end of the century, about 90% of our summers will be. Now, if we are following the green trajectory or lower, those percentages decrease, but we're still going to see a number of very hot summers. And we care about that heat because it has a direct health impact on people. So we expect to see increases in heat-related illnesses, hospital admissions, and deaths amongst vulnerable populations. Part of it's due just to the increased heat, but the other part is due to humidity. So as temperatures rise, humidity typically increases here in New Jersey. And what happens is, as it becomes more humid, our bodies are less able to cool off effectively. We cool off by sweating. That sweat evaporates. And when it's humid out, that process is inhibited. Basically, things don't evaporate as effectively when it's humid, so we don't cool off as effectively. Some other things that we want to consider for New Jersey is the urban heat island effect. That's pictured down here on the right. And the urban heat island is created when you have a bunch of impervious surfaces like pavement, concrete, the roofs of buildings that absorb solar energy and then re-radiate it back out as heat. When you have a really high density of those, a bunch of them in one location, like in a city, it causes the local temperatures to be several degrees warmer than the local surrounding forested or more rural environments. So New Jersey is one of the more urbanized states in the Union, especially along that corridor from Philadelphia to New York City. Think of, you have Trenton, you have Camden just across the river from Philly, you have Newark and the areas in the northeast part of New Jersey. So the urban heat island is a very big concern for us. And as we do our planning and adaptation measures moving forward. So some other effects of higher temperatures that we want to consider. Certain pollutants like ground level ozone are created at a higher rate on warm days. So expect to see increasing pollutants of certain types. That's bad for people with asthma and other respiratory illnesses. We expect to see the prevalence of certain types of diseases like West Nile virus that are carried by mosquitoes. Basically, mosquitoes' range is constrained by how cold it gets during the winter. So as the temperatures warm, they can move into new locations and bring diseases with them. Our infrastructure wears and tears more readily on hot days. You see that with bridges. And as it warms up, we turn our ACs on, pulling more energy. And if we're all doing that at once, that puts more wear and tear on our utility systems. And finally, I like to focus a little bit on our water resources. So one of the benefits of warming temperatures is that we have a longer growing season. So New Jersey actually has a pretty vibrant agricultural industry, and we'll be able to see new crops maybe being grown. But that also increases water demand for irrigation, as well as water demand at the residential and municipal scale. Basically, we need water to drink and cool off. So we do expect to see a strain on our water resources moving forward. Okay, so now I'm going to shift to talking about sea level rise. And sea level rise is a direct consequence of increasing global temperatures. So pictured here, I have curves comparing New Jersey's sea level change since 1920. So that's what that black horizontal line represents here. New Jersey's in green, compared to New York City in orange, and then the global average in black here. So what we can see is that New Jersey's sea levels have increased by about 1.5 feet since the early 1900s. And that's a little more than double what the global average is. Again, the global average is this black curve here. So there's a number of reasons why New Jersey's increasing faster. So at the global scale, global sea levels are primarily driven by the melting of ice sheets and glaciers, and then the expansion of the oceans as they warm up. Basically, any material that you warm will expand a bit. Think of like a hot air balloon. The balloon expands because you heat the air within the balloon. So that's why they have the little torches on them. And the same is true for the ocean as well. As the ocean is warming up, as the climate changes, it expands just a bit, but there's just so much ocean that we do see that as a noticeable change on the surface. And then New Jersey has a number of other factors that influence its local experienced rate of sea level rise. Now, I don't want to get into all of them because there's a lot, but the one that I do like to highlight because it's really easy to wrap your head around is our lands in coastal New Jersey are actively sinking over time. We call that process subsidence. It's broadly a natural phenomenon here in New Jersey. But what that means is we have global sea levels increasing, our land sinking, and so in New Jersey, we experience a much higher rate of sea level change compared to the global average. And we expect that trend to continue into the future. So this graphic here is a little complicated, but it's showing sea level rise for moderate greenhouse gas emissions relative to the year 2000 for New Jersey. So just to break this down, because there's a bunch of lines here, really the simple thing to focus on is the tan region that's highlighted here is the likely range of change. So we're pretty sure it's going to fall somewhere between those two lines by a given year. The red line represents a median estimate, basically our best guess by that given year. So by 2100, we expect our sea levels in New Jersey to be about 2 to 5 feet higher than in the year 2000. And the red line here is about 3.3 feet. So that's about a meter. So that's kind of where if you had to place a bet, that's where you'd put it. Now, when we think about sea level rise, people immediately think about the encroaching tides, land being swallowed up by the ocean. And that is an issue, but it's not the most important issue in terms of climate change planning. What's a much more pressing issue is how the storm surge from large storms like hurricanes interacts with sea level rise. And this graphic here displays that very well. So on the left, we have a house on land, and during existing high tide, it's protected. Now, let's say we have a storm like a hurricane move through. That storm generates storm surge. You can see it pictured here. Storm surge is just the elevation of the water surface due to winds, pressure systems, and stuff in the storm. And you can see the storm surge basically just stacks on top of the existing high tide. But the house is built to today's standards, so it's protected. Now, as sea levels rise, we change that baseline from high tide and raise it up, and then the storm surge just now stacks on top of that higher baseline. And that means that the storm can now flood the house, flood inland further and more deeply. So we anticipate seeing this more frequently in the future in coastal New Jersey, and to some degree we've already seen it with Hurricane Sandy. So pictured here on the right is the storm surge extent from Hurricane Sandy throughout New Jersey. And it's been estimated about 13% of the property damage from Hurricane Sandy in 2012 can be attributed to human-caused sea level rise. Basically, because sea levels were higher due to human influence, Hurricane Sandy was able to cause about $4 billion more worth of damage throughout the state. And when we think about changes in flooding in the future, today's really big coastal flooding event, we expect that to occur about 5 times as frequently by 2050. So we're going to see this more frequently because with sea level rise, you don't need as big of a storm to generate very big levels of flooding. Now, the other thing I want to focus on with sea level rise is this encroaching tide. We call this tidal flooding. You also hear this called nuisance flooding or sunny day flooding, and it's pictured here in Mantoloking. And what you can see is it's not really dramatic. It's a low amount of flooding. In this case, the roads flooded, the homes are cut off, but there's not a huge amount of damage. But what's really worrisome about tidal flooding is that it's frequent. So we're seeing this kind of flooding happen more frequently just as the tides are very high. Not really due to a storm or anything, just really high tides that cause on-land flooding. And by the end of the century, we think probably, for example, in Atlantic City, about 3/4 to basically every day of the year is going to have some level of flooding in Atlantic City. So that raises questions for people, communities' adaptation measures, or they even want to live in the coastal zone at that point or move out, just due to the nuisance, not really so much the total amount of damage. Okay, now I'm going to switch to talking about precipitation and particularly rainfall throughout the state. So historically, our rainfall in New Jersey is variable. We have big swings from year to year, and that's what's pictured here in this graphic. So we have the total average rainfall throughout the state, and that's what that green line represents for each year. And we have these black bars that represent averages each decade, just to see what the trend may be over the long term. And as I mentioned, there's a lot of swinging back and forth from very wet years to very dry years. But overall, our amount of rainfall in New Jersey hasn't changed much over the past century. We have gotten more strong swings from very wet to very dry years in recent decades, though. But where there's a more interesting and impactful story is with extreme rainfall. So really heavy, severe rainfall has become more frequent in New Jersey, and we think it's going to continue to do so. So I don't want to bother you with all the complexities of this graphic on the right, but what it's basically showing is the number of days per year where some part of New Jersey experiences more than 2 inches of rainfall. And since about the 60s, the number of those kind of really big rainfall events throughout the state has increased. So by the end of the century, we're thinking that our really big rainfall events are going to give us about 2.5 to 10% more rain and throughout most of the state. But in northern New Jersey, it's actually going to be much bigger, about 20 to 25%. So our rainfall events are becoming more frequent, or our heavy rainfall events are becoming more frequent, and they're becoming more extreme. So the result of that is pretty straightforward. If it rains a lot, there's typically a lot of flooding that can cause property damage. It can harm people. Floodwaters themselves are pretty nasty, so they can contaminate food and water supplies. Throughout parts of New Jersey and some of our urban areas, we have combined stormwater drainage as well as sewer lines. So that's pictured here. So we have our stormwater that's being combined with sewage from a house, for example. And typically that system works by just combining them and sending them to the wastewater treatment plant. But if you have really severe rainfall, that system can become overwhelmed, and it has to siphon off that water, or that sewage rather, into local waterways like a river or the ocean. And so that's a bit of a public health problem. You don't want to be eating, shellfish out of that water, for example. And finally, thinking about our water resources, we expect to see more rainfall during heavy events and then kind of drier conditions in between. So we're going to see these big rainfall events and then a few months where it's going to be dry, probably not very much rain, then another big event. That's how we think the distribution of rainfall is going to be in the future. And then when we're thinking about storms, so we're talking about extreme rainfall, but let's think about the biggest storms that we have to deal with, which are hurricanes. We think those are going to become more intense in the future. So warm water and warm, humid air is fuel for a hurricane. It makes it more intense, stronger winds. So as the atmosphere warms into the future and the ocean, we expect our hurricanes to be stronger. Basically, we're going to see more categories 3 and 4 versus 1 and 2. We expect that they're going to be able to intensify more rapidly before making landfall. And we expect them basically to be able to rain a lot more. So what that may look like within the state is, if you remember Hurricane Ida in 2021, that could be what some of that rainfall looks like. So Ida was really kind of a harbinger of what our flooding in the state with climate change may look like, and really underscores how susceptible we are to flooding. Now, that doesn't mean that every storm is going to be Ida. We're not going to be waterlogged that heavily, but we're going to be trending a bit more towards it. So some other things that are just interesting as we consider climate change is with our food resources. So in terms of agriculture, there's optimum growing latitudes, basically due to temperature, for growing certain crops. So pictured here on the right is the plant hardiness zone for New Jersey. Basically, it's a guideline for what kind of crops can grow where based on how cold it gets in the winter. And as temperatures warm, we expect this map to change. Basically, we may lose out on some of our crops that we grow within the state because it's going to become too warm for them, but we may be able to plant new crops that are more hardy towards warmer climates. So crops that are maybe grown further south traditionally, we may be able to start growing here in New Jersey. So this could be beneficial to melon, okra, sweet potatoes, for example, but certain crops like potatoes, lettuce, spinach, and broccoli, we may not be able to grow as effectively here within the state. So it's an interesting shift. And if we want to consider our offshore food resources, so aquaculture and fisheries, I didn't really get into ocean acidification, but that's also an issue around climate change. But the ocean is becoming a bit more acidic, and that causes shellfish populations to not be able to create their shells as effectively, and they are threatened moving forward. So shellfish populations for aquaculture may be reduced, and we expect to see changes in fish distributions. So pictured here in the bottom, we have a map of where basically the mean location where most of these three species were caught from 1973 to 2019, where the darker dot indicates the more recent year. And what you can see is they've all broadly been moving north. And what's happening is they like colder waters, they're moving north to get into colder waters. So the distributions of the type of fish that we can catch offshore may change. So what's not pictured here is probably some more southern species moving into New Jersey waters that may be able to be caught in the future. Okay, so I realize I gave you a bunch of doom and gloom type stuff, but as I emphasized in the very beginning, a lot of this and the magnitude of it is dependent on our actions that we take today. So one of the empowering things is that we can indeed act. So I'm going to run through basically what the state's doing and then what we can do individually in two big categories. And the two categories we're dealing with climate change is first, mitigation. So that's reducing or preventing greenhouse gas emissions. If greenhouse gases are what's causing climate change, if we reduce or don't emit them at all, then we are reducing the amount of total warming and climate change that we're going to experience. So at the New Jersey scale, the state's passed its Global Warming Response Act to reduce its emissions by 2050. And it's doing this in large part by increasing energy from renewables throughout the state. So we've been doing a very big push for offshore wind. And basically what this does is it lets us reduce our usage of fossil fuels for our electricity. There's also been a big push throughout the state to switch to electric vehicles, again, benefiting from renewable energy. There's also a push and policies actually within New Jersey to restore and enhance our natural environments. So forests or coastal wetlands, as they grow, they absorb carbon dioxide from the atmosphere and they just lock it away for a long time. So restoring those environments or protecting them ensures that carbon dioxide is being removed from the atmosphere. And we tend to focus on forests, but really our coastal wetlands, especially here in New Jersey, are really great. Great at reducing or absorbing carbon dioxide. So think about our salt marshes along the coast. But that's kind of state scale. So what can we do at the individual scale? So at home, we can work to improve our efficiency, maybe with better insulation for our homes or energy efficient appliances, or choosing renewable energy if we can. We can eat a plant-rich diet, limiting meat. Basically, growing plants creates a lot fewer greenhouse gas emissions versus raising meat or cattle, poultry, and the like. We can reduce our car usage or limit air travel. Air travel is a big one, actually. People don't realize there's a lot of greenhouse gas emissions from air travel. So if we can limit those, that's great. And in our community, we can work to restore and enhance our green spaces, planting those trees, making it vocal that you want a park, or you want to protect that park. And again, supporting investment in renewables, basically being vocal about it. Now, the other camp is adaptation. So we can mitigate a lot, but there's a certain amount of climate change and impact that we're going to be dealing with. And so adaptation is taking action to avoid those impacts. So again, at the state scale, we have the Blue Acres program, where the state is offering to buy people's homes. They're in flood-prone areas, and they're just not rebuilding in those locations. There's also other programs for regional action plans for climate change. So we have one here in the Two Rivers region in Monmouth County, where they're looking towards coastal protection infrastructure, raising homes that will deal with flooding, creating resilience committees locally so that communities are talking with one another. Again, we can also enhance our forestry cover, basically plant some trees that help deal with the urban heat island. And one thing that I really like to encourage is community engagement and involvement. Even if you're not of voting age, getting involved in the community and being vocal about it is important, and lawmakers hear that and they act accordingly. Now, again, at our personal individual level, we can assess our flood risk at our homes. There's a number of tools online, including our Flood Mapper tool at the Climate Change Resource Center, that can help you determine if you have some flood risk, and you may want to consider elevating parts of your home. You want to prepare for hot weather. It's good to know where nearby cool locations like a mall or a library are, especially if you don't have great air conditioning in your home. We can prepare for wildfires by making sure flammable material is not around our homes if you live closer to a forest and more of a rural area. And we can prepare for worse air quality by making sure you have medication or emergency inhalers if you or a loved one has asthma, for example. And the last thing that I really like to emphasize is community preparedness by coordinating with our neighbors. In today's world, we tend not to get to know our neighbors or our community very well. I'm guilty of it myself. But during any sort of hazard, whether it's climate change, whether it's a natural hazard, or some other disaster, we find that communities with a lot of good cohesion, where neighbors know each other, can check up on each other, they tend to weather the storm a lot better. And so I really like to emphasize that importance of really getting to coordinate, or at least know your neighbors, and create plans with them. And then finally, volunteer where possible, get involved. Again, making your voice known that this is an issue that you're worried about or that you want to take action on. People in power listen to that if enough people are talking about it. So I always encourage that as well.
That was fantastic, James. Thank you. People will be able to go over that very comprehensive New Jersey focused adaptation to climate change presentation. So thank you so much.
Well, thank you for having me, and I'm happy to answer any questions by email in the future. So feel free to send any my way. Thank you very much.
Great. Thank you. And Sheila, thank
James.
you also.
I just wanted to say one more thing to the students regarding the instructions for the team presentation. Make sure that you go onto the Envirothon website and look over the judges scoring sheet, because then you can get a really clear picture of how our judging panels will evaluate your presentation, and you can kind of use that as as a framework for your presentation. So just keep that in mind when you're preparing for your presentation. And I don't know if any of the students that are present right now have any questions for me about the nuts and bolts of the team presentation.
How many pages of the Flipboard are we allowed to use?
Unlimited. That is we got, we always have lots of flip charts and markers in place. You're only going to have 5 minutes to prepare, so I don't know how many pages you can prepare in that amount of time, but whatever you need, you will have.
So before I start, I'm going to be giving the Wildlife Station presentation. Becky LeBoy and Holly Reynolds coordinate this station. Becky prepared the slideshow and she's not able to be with us. And Holly will answer questions following the slideshow. New Jersey is an extraordinarily diverse state in terms of wildlife and the ecosystems they inhabit. There are over 1,000 different species of animals in our small state, whose ranges may expand throughout the state, and for some animals, their ranges are very small and specialized. Diverse wildlife populations are valuable indicators of a healthy environment. Understanding a species' survival requirements is the first step in ensuring the continuing existence of that particular animal. Proper protection and management of habitat will support optimum populations. The Wildlife Station offers 2 different components that test students' knowledge about wildlife and their habitats: the written test and the hands-on test. All questions this year are through the lens of climate change. Written test question topics focus on common wildlife species inhabiting New Jersey, with a special focus on New Jersey's endangered and threatened species, their natural history, conservation practices, various habitat types found in New Jersey, and how climate change is impacting New Jersey wildlife and their habitats. Next slide. Wildlife species on the written test mainly focus on vertebrates. Questions are species specific, but may focus on other taxonomic groups such as classes of animals. Some questions do refer to invertebrates with a focus on pollinating insects. Prominent invasive species in New Jersey are also addressed. Be familiar with conservation practices designed to protect New Jersey's wildlife, specifically from climate change. Questions about the natural history of wildlife may include life cycles, breeding, nesting, rearing young, finding food, adaptations, structures and functions, plant and animal interactions, and biodiversity as it pertains to the impacts of climate change. New Jersey has a diversity of habitat types. Be familiar with various New Jersey habitats such as wetlands, woodlands, a salt marsh, and barrier beaches. Be familiar with their vegetative and hydrological components. For example, a salt marsh habitat may be tidal, have brackish water and grassy salt hay vegetation that supports certain estuarine species that cannot live in a freshwater system. Be able to connect species with their appropriate habitat type. Understand habitat management as it pertains to the impacts of climate change. For example, saltwater intrusion on nearby Atlantic white cedar forests and high temperatures and periods of drought on vernal pools. What wildlife species will those impacts affect? The impacts of climate change are woven into every question. For example, questions include how wildlife and their different habitats are impacted by rising sea levels, flooding, extreme precipitation, and acidification of our oceans. Questions may address how these changes impact different New Jersey wildlife species, different classes of animals and their populations, as well as their habitats, and how we can mitigate the impacts of climate change to conserve and protect species. Most questions are presented in multiple choice format. Some may be matching and true and false. There may be pictures depicting species that you will need to identify. The hands-on test component is interactive and requires careful observation of wildlife artifacts and listening to wildlife calls and sounds. Questions may include looking at specimens, fur, feathers, bones and skulls, scat, tracks, and photos to identify species. You will be required to listen to calls and to be able to identify the species making the call. The questions may then extend to the habitat in which the species lives or the natural history of the species. The questions will also pertain to climate change. For example, you listen to a call made by an endangered species whose habitat is under threat from saltwater intrusion, and you are asked to choose which type of habitat that species resides in. To help you study, utilize the resources found on the njenvirothon.org website, and feel free to reach out to Holly Reynolds or Becky Lavoie. We have Tim Robinson here, who's from the Burlington Soil Conservation District. Tim is also a longtime champion of our Envirothon, New Jersey Envirothon. He's a non-point pollution expert and also an expert in erosion and water quality and sediment control. And he'll be talking about the current issues station. So thank you, Tim.
All right. Well, James did most of the presentation for me, so thank you. But all this can be found on our website at the NJ Envirothon under the current issues tab. This PowerPoint is there too. It's just a little rundown of what the test is going to be like. So again, we can find it at NJ Envirothon and do the current issues. And the test is 2 parts, 15 minutes each. The written part is 25 questions, 2 points, and I'll go through the resources needed for the hands-on, or the written, and the hands-on part is going to be the National Envirothon resource. So it's on our website, but it's also on the national website too, so you can see it in both spots. And the hands-on will be more graphs and charts, and everything will be based off of the graphs and charts, and the written part will be based off of the 3 resources that we found, which goes right along with what James his presentation did for the Rutgers climate change. So let's just go through. This is the climate basics. What's weather versus climate? What is climate change? What are greenhouse gases? We're going to ask, what's carbon dioxide? What are the global warming potential gases? What are the fluorinated gases? So stuff along those lines that we want to go over. Again, it's, weather versus climate. But more, what is the climate change? What's the weather? What's the temperature climb? What's the sea level rise? Is it accelerating? Is it declining? What's going to happen, because of sea level rise? What's base rates? Does it affect industry? Does it affect farming and agriculture? Does it affect tourism? So, think of the economy. Think of extreme precipitation. Part of our job is looking at how land is manipulated and influenced by different rain events. So, say like a 10-year storm versus a 100-year storm. Because of climate change, are we seeing an increase in intensity of storms? Does this affect our health? How does it affect our health? Does it, degrade our air quality? Does it allow for different vectors of disease to happen? Storm-related injuries, is there flooding? And all the craziness that comes with the flooding. The economy, because of flooding, there's going to be insurances, and there's storms like Superstorm Sandy. There's going to be less people going to the beach resorts. Think of like how everything is interrelated. The environment, because of we're a very urbanized state. So how does our environment, how is that going to be affected by climate change? All these things. Again, what are the greenhouse gases? And we just want to go over some sample questions for everybody. So just to get an idea of how the questions are going to be shaped for the current issues, we thought this was a good chance to do this. So let's just go over it. There's only like 7 questions. This is not a long presentation. So which of the following best describes the difference between weather and climate?
Tim, are you advancing through the slides? Because
Are you seeing me advance it? Is
no,
it moving?
no.
If I move like this, well, does it work?
Yes, you're moving it.
Okay, great. All right, so let's go to the first sample question. Which of the following best describes the difference between weather and climate? A, weather is the description of long-term patterns of atmospheric behavior in particular areas, while climate is the condition of atmosphere are over a short period of time. B, weather is what conditions of the atmosphere are over a short period of time, while climate is the description of a long-term pattern of weather in a particular area. Weather and climate are the same thing. D, climate is what you expect, while weather is what you get. So B, weather is what conditions of atmosphere are over a short period of time, while climate is the description of a long-term pattern. So we can just keep going. So our second resource is the Scientific Report on Climate Change 2020. And again, this is pretty much what James went over. His presentation was on our third resource. Again, we want to go over temperature, precipitation, sea level rise, acidification of the ocean, air quality, water resources, agriculture, forest, wetlands, terrestrial carbon sequestration, and different types of systems. So what are the significant changes that New Jersey will experience as atmospheric levels of carbon dioxide and other greenhouse gases increase? Decreases in temperature, less variable in precipitation and fewer storms, increase in temperature, variability and precipitation frequency, and intensity of storms, sea level rise, ocean acidification, and associated impacts of ecological systems, natural resources, human health, and the economy, no changes in the environment, increase in temperature and humidity. Anybody? B, the increase in temperature. So the atmospheric levels of carbon dioxide and other greenhouse gases increase. New Jersey will experience significant direct and secondary changes in its environment. What is the primary driver of the climate according to the report? So we will ask direct questions from the report. Sometimes it will be very specific of percentage increases or decreases or what a level is. And everything will be linked to a report. So if there's a question, we'll know where the questions come from. So if you want to debate it later after the test, if you thought that you had a question right and it was something different on our test, you can debate it, and we'll have the resources at the Envirothon to show you where we got that answer from. So the primary driver is the decrease in atmospheric level of greenhouse gases, increase in atmospheric level of greenhouse gases, land use changes like afforestation or a reduction in the use of fossil fuels. Anybody? B, increase in atmospheric levels of greenhouse gases. What is the reason for the stronger impact of temperature increases in New Jersey compared to other regions? Lack of open spaces for cooling effects, variability in precipitation, sea level rise, increase in snow accumulation. A, lack of open spaces. The report states that the high urbanization. So the report states a lot of the urbanization of New Jersey is a indicator of climate change for us and a big factor of increasing temperature. So this is the climate report that James went over. So again, it's a lot of the summary of weather, emission scenarios, agriculture and sea level rise vulnerabilities. So think of like our blueberry fields, return periods, how often things happen. Again, intensity of storms, changes between New Jersey. Think of like Industrial Revolution. Think of how Industrial Revolution added to greenhouse gases, and you can relate that to different temperatures, different atmospheric conditions. So how do scientists project how the climate may change? By looking at historical data, by using a crystal ball, by conducting experiments, by using a range of illustrative scenarios, by using a range of illustrative scenarios. So think of think of the big picture of all the situations that need to be incorporated and thought about when folks like James study the climate. Think of the socioeconomic assumptions, the climate, the migrations, the air pollution. All these things weigh into climate change. How does sea level rise affect New Jersey's coastal farmers? It decreases the probability of saltwater intrusion in near-shore freshwater wells. It reduces the risk of erosion along tidal ways. It raises the baseline for coastal flooding. It increases crop yield. So if you think back to James's his picture of a house on a hill with the flooding, this is kind of what it's talking about with the baselines for coastal flooding. It raises the baseline for coastal flooding. What does 100-year event mean in terms of probabilities? Is it 100% chance every year we're going to get it? Is it 50? Is it a 1% chance? Is it a 10% chance? we just move the decimal point and it's 2 points or 2 spots, and it's a 1% chance. So so every storm, we have a 1% chance of it being a 100-year storm. So if it's a 10-year storm, you would change it so it'd be a 10-year storm. So you have a 10% chance of a 10-year storm. But this weighs into a lot of how they design stormwater basins and how stormwater is controlled in new developments and redevelopments. It directly relates to flooding and insurance issues and health issues. So like this is a very important indicator of climate change. And this is a sample question. I'm going to give everybody like 5 minutes to go through this. This is like sample question for hands-on. And you can see the chart up top and the questions 1 through 5. Let me see. On the bottom. So if you guys want to take 5 minutes and go over this. This is our last slide before questions. All right, so we can just go through the chart real quick. What would be the minimum typical pasture area needed for 15 horses? So we go up and find horses in the chart. You go down to area needed. So we would need 400 square feet per horse. 400 times 15 is 6,000 feet. Which animal type has a higher typical area needed versus area needed? So we go area needed versus typical area needed. We can just compare the two. So we can say dairy cow. What animal type would be ideal for a farmer that wanted to raise 30 individuals with a pasture size of 120 square feet? So we can go through. And as James was saying, we can see the size of pastures and the amount of sequestration for carbon that it takes to grow livestock versus eating plants. So think of, again, it's just the overall impact of each part of our lives that we might not think of climate, being part of climate change, but realizing that, a typical animal, an animal requires a typical spot that requires an amount of food that needs to be required to feed that animal, which requires an amount of land and area. It all weighs into it. But again, James did most of our presentation of getting into the details. He did an excellent job, and it's really going to be, at least the written part is going to be pretty much directly related to his presentations, because it went directly off of the different Rutgers reports for 2020 and 2021. And as we can see, the hands-on will be directly related to adapting to climate change for the Envirothon natural resource study.
So thank you, Tim.
All right.
And
Thanks, Lily.
we will move on to our final station. It's been very patient. We have another longtime Envirothon champion with the USDA, NRCS. He's a soil scientist. Fred Schoenagel is on, and hopefully he can unmute and start his presentation.
Thanks for inviting me, Lily, and welcome everybody. It's intimidating being the last presenter, but that's okay. We'll just bring this to a close here. So I run the soil station. As Lily said, I've been involved with the Envirothon since about 1996. So it's always been a lot of fun to be a part of it. NRCS has always been a part of the Envirothon, particularly the soil station and helping out with other stations. And it's exciting having an opportunity to do this in person again. And actually had to go back through my notes to remember how the soils station was set up. So I'm going to give you like kind of an overview of the soil station, maybe a little basic soil science. I don't want to take up too much time, but just give you an overview of what's to be expected when you come to the soil station and some information that could be important for completing the tests. So, all right. So the soil station, just like a lot of the other stations, there's two parts to it. There's a hands-on part and a written part. They're each governed by a test, and each test is 50 points. And like Tim said, you get a half an hour at the station, so you get 15 minutes at each part to complete each test. So they're discrete parts of the station, and you'll come to each part, and then we rotate you halfway through. So each one of the parts, each one of the tests has certain certain composition, certain makeup. The testing materials will always be provided to you, and we try to be really interactive. Even the written part has a lot of things to look at, and kind of like what Michelle Hatfield did a really good description of topo maps. So I'm not going to go over that, but the written part, you'll be given some maps that you get to study and answer your questions with. So it's topographic maps. There are soil survey maps that are inventories of soils mapping that NRCS has provided over the years. And along with the soil survey maps are soil survey interpretation reports. Someone else writes the written test at a cohort who does that, so they sort of craft this test on their own. And also we try to only take information from our Soils Online study guide, which is the guide that's online for the Envirothon, just like the other sections. So all your information will be provided either from the online study guide as you study or prepare, but all this information will be provided to you the day of the test, so you'll have it there to look at. Some of the skills that the written test looks at or wants you to work through are identifying a particular location on a topo or a soils map, using the soil survey map to identify the soils that are mapped in a particular location. And then you use interpretation tables that relate to the soils maps to help make decisions on the use and management of a particular location. So that probably all sounds like gibberish, but here's a written part of the written soils testing materials. This is a soils map. This is from a previous Envirothon, so you can see they sort of delineate an area, and then you look at the soils map. There are symbols on there. You plug them into an interpretation table, and you can interpret things about the soils map. So this is it's not very much, but this is an example of an interpretation table. There's a mapping symbol that you get off of the map, and then you can read different interpretations to see the best use and management of the soil or what limitations it might have. So again, all this stuff's going to be provided to you when you do the written part. There's a topo map, which Michelle described very well. So along with identifying watersheds and water movement and things like that, soils change based on topographic position and geographic position. So we also use topographic maps in our soils work, and you will probably use that as in conjunction with the soils map to determine suitability of a site, kind of show those relationships between the topo map and the soils map. So it's a lot of maps, a lot of tables and things like that. But again, everything should be laid out for you to help you answer this question. There are also typically some questions based on some soil physical and chemical properties and other things from the online study guide. There may seemingly be some overlap between the hands-on and the written part, but it's an attempt to sort of kind of reinforce and maybe pull from some of the most common information that you might have studied to prepare for going to the soil station. So All of the questions are usually there in a more simple format. I think there might be a couple of fill in the blank type questions. A lot of them are multiple choice or choosing from a list or something like that. So you try to have most of the answers presented to you. And probably the most important thing for both parts of the soil station and for the other stations too, just sort of calm yourself down and read the question, because if the question says refer to the topographic map, make sure you're looking at the topo map. Make sure you're looking at the interpretation table. It's the same with the hands-on. So just take a moment and read carefully each one of the questions so you know exactly what information to use. And there's a proctor, someone in charge of each section of the soil station. So you can always ask that person for guidance too. All right, so I do the hands-on part, and testing materials. Since this is hands-on, you literally have things that you have to look at and touch and interact with. So there's usually, I don't know what they call it, how to describe it. There's displays or exhibits of soil and geologic material samples. There's usually a soil pit, either a hand dug or dug with a machine, kind of based on what we're able to do at a particular site. And also, just like with the written part, information provided in the Soils Online study guide. So the skills I'm looking at to help you complete the test, you're going to be estimating the soil texture of soil samples by feel, which unfortunately I forgot to show an example. There's a soil texture flow chart which will be provided to you to serve as a key to work your way through soil sampling. There's identifying, you may have to identify different rock types or different kinds of geologic materials. And we give you little hints on how to do those things, but it's something we sometimes do. I'm not sure exactly what we're going to do this year, but some sort of an identification of something. Identifying soil properties using these displays or exhibits or samples, and also potentially from the soils pit, and evaluating site characteristics that might be important for use in management, looking at the slope, some sort of surface features like stoniness, things like that. So this is what the hands-on part kind of looks like. There's various containers, they're all labeled. Some things you can't touch. I won't put a sign there if you can't touch something. It's just to look at. Some things you can interact with, like the soil texture in this bucket. There's usually a soil pit, and we normally ask a couple questions from a couple different layers or horizons, and we will mark those with golf tees, and we will name the color, describe the color of the golf tee related to that horizon. So that's a part of it. You have to get in there and interact. Don't be afraid, because you won't be able to answer the questions if you don't interact with these things. And again, it's the hands-on part. We want it to be hands-on. We want you to get in there. So one thing I wanted to point out, when we used to do on-site soils trainings, I would have an example of a soil pit, but sometimes it was at the training location. So when you get to the competition, the soil may look completely different, or it may look completely different from the first or only soils example you've ever seen, soil pit you've ever seen. So just know that depending on where the soil station is located on a site, depending on where the site is located within the state, the soil could look very different. So even year to year, if we continue these, if we're able to continue in-person events, like don't expect to see the same soil pit year after year after year. We have 3 redundant setups for the hands-on to help run everybody through the stations faster. So, but all 3 of those soil pits at the station will be almost identical, or at least very similar. So at least that year, no matter which soil pit you go to, the answers will be the same. But just don't be freaked out if the soil looks vastly different than what you may have seen in the past. And we utilize the soil pits to answer different questions. Some soils have a lot of rock fragments. We may have to ask a question about that. These soils are not very deep to bedrock. You can see they're less than 20 inches. So something related to that. It's always going to be a physical property. Could be something about soil horizons, the presence of different layers of horizons, the lack of horizons, color, where does the soil get its color from? why is the soil green? It's like we actually have green soils in New Jersey, but so we could look at some physical properties, color being the most obvious one. We also will ask questions about soil texture. And like I said, there will be a flow chart that sort of helps you describe in the field what soil texture is. But to understand the concept of what soil texture is, it's a combination of the different particle sizes that make up the soil, all of those that are less than 2 millimeters in size. So sand, silt, and clay. You mix those together in different proportions and you get a soil texture, what we call a soil texture class, that's represented by the soil textural triangle. This stuff is all on the online study guide too. So some of your terminology may be relevant: texture class, soil texture, texture triangle, and the different size separates. So soil texture class represents that combination of those different soil particle sizes that are mixed together. And this is a chart or a diagram that shows the relative sizes of sandstone and clay, sand being the largest, which goes from a little less than 2 millimeters to about 0.05 millimeters. Silt, which is a little bit smaller, it goes from about 0.05 millimeters to about 2 microns, which is microscopic, and then clay is microscopic. So the one reason we want you to not only do the texture by feel techniques to get a little sense of what different soils feel like, we want to talk about what these different soil particles represent. Sand is the largest particle. Soils that are very sandy can be very droughty and infertile. They don't hold on to anything. They can't hold on to nutrients. They can't hold on to water. They're like very small rocks. You have silt, which is smaller than a sand. It kind of gives the soil like a soft or smooth feel. It makes the soil feel like maybe like bread dough or baking flour. It makes the soil feel nice and soft. It kind of fills the soil up and loosens it up a little bit more than say a clay would. But soils that have a lot of silt can actually be very unstable and easy to erode. So it's important to be able to identify a silty soil, because those are the ones that are going to be very susceptible to erosion. The silt particle lends itself to being transported by water. The clayey soils, when you get down to the clay particle, they impart certain properties. They're kind of the active part of the soil. They're microscopic, and they actually can hold on to water molecules and nutrients, and they stick together really well too. So a clayey soil can be hard when wet and hard when dry, sticky when wet. Holds the soil together, so it may help with erosion, but it also can hold the soil together so well that it holds on to water and nutrients and can make the soil almost impermeable. So understanding not only the field texture of each one of these particles, but also their part that they play in soils as far as soil function goes is really important. And try to relate that back to the uses of soil or the suitability of soils for certain uses. So you take the soil particles, the sandstone clay, you aggregate them together, and then you get soil structure. So this is another thing that we will typically ask a question about. You saw earlier my one display was a container that said soil structure. So we may actually have soil structure examples either taken from the soil pit or brought there to have you evaluate. And then in the online study guide, we have this information as well. And we want you to be able to learn to identify these different structure types, because they, again, lend themselves to different functions of the soil. Some of the more rounded or spherical or blocky structure types are more agreeable to water and air exchange between the atmosphere and the soil profile, and also make more space, more pore space in between the pieces, the aggregates, that allow roots to penetrate, that allow water to move down through the soil profile quickly, and allow air to be exchanged between the atmosphere and the soil profile. If you get more of a horizontal type structure like platy, lenticular, or a larger structural size like a larger structural aggregate like prismatic or columnar, those don't allow for vertical water movement or air exchange. They can make the soil kind of dense and tighten up and hold on to water and not allow it to move through the soil. So these, by identifying soil structure, you get a sense of like how that soil functions, how it would interact with plants, how it would interact with air and water. So, so we want you to get a little better sense of what soil structure is all about. You take the sandstone clay, you aggregate those pieces together, those particles together, and they turn into soil structural units. And this is what happens over time. As a soil forms, it develops the structure. So we zoom way in. This is 1/10 of a millimeter. You see these two sand or silt grains, and then glued together by different types of quote unquote glues. And they could be anything from calcium minerals or calcium ions, clay minerals, iron oxides, or more importantly, organic matter. Those things can help bind these particles together and eventually aggregate them into those soil aggregates or heads that make soil structure. And as part of that understanding of soil structure, we may ask questions about water movement, either evaluating the soil pit itself or looking at some soil structure examples and asking how do you think water would move through that, or which of these examples of soil structure would allow water to move more quickly through it. So just know that the leftmost one is granular, and you see vertical water movement. To the next one, second from the left, is prismatic, which you see water moving vertically, but it's also kind of taking 90-degree turns there as it goes from the top of one prism to the next. The third one from the left is subagular blocky, again allowing vertical water movement, and then the platy, again, is sort of holding that up. So anytime you see horizontal movement or hold up of the water, it's not moving through as quickly. And this doesn't imply that some soil structures are good and some are bad. One thing as a soil scientist interpreting soils, I don't like it when people say, this is a bad soil, this is a good soil. There's no such thing as a good or bad soil. Some soils are just better suited for different uses. If you want a soil to be wet, which in some cases you do, you actually want a structure type that's going to hold the water up. Like we've actually created wetlands in some of our work with NRCS, and we've actually sort of degraded a good, a vertical movement soil structure like blocky or granular. We've actually compacted it to make it more like platy, to hold the water up and slow it down, and to create, let's say, for example, wetland conditions. You don't want the water to move out of the soil, so you have to change that soil structure. So, in that case, to make a wetland is a good thing. So that soil is well suited to that use. And a lot of times when we get to the point of asking about interpretations, it's more of that. It's not, this is a bad soil. It's just think about all those physical properties and some chemical properties too. Which ones are the most suitable for that particular use? Which is the whole reason why we interpret soils in the first place. Not to just describe them to learn more about them, but to figure out which ones can be used for certain purposes, and also how to protect them, how to conserve them. So we're also going to, outside of the soil pit and the exhibits, we're going to look at some site characteristics. The two most common questions we ask about the site are related to the slope. So slope is just the change in elevation over the change in distance. So how many feet or inches of height raises or lowers in elevation over a set distance, and calculate that out, and that is the slope gradient. So a steeper slope will have a larger number, 35, 60, 80%, whereas a shallower, gentler slope will have a lower slope gradient percentage, 1 to 2%. And as we showed you before with topographic maps, as those contour lines get closer, the contour interval changes and the soils or the site is getting steeper, where those lines move away from each other, but the area is getting flatter because that gradient is not changing as quickly. The elevation doesn't change over distance. So we could ask you something about the actual slope of the property, of the location, or just some questions in general about what does slope gradient represent? The other one we ask about, this actually is pretty relevant for a lot of agricultural uses and other uses of the soil, is something called aspect. So this is the compass bearing that can be described in different ways using degrees or compass direction. It's the direction that the slope faces. So one way to think about the aspect is if you're standing on a slope and you're sort of you have your feet pointing down slope as you're standing on the slope, the compass direction or the direction that you're facing as you look out is the aspect. So a north-facing slope, if you were standing, your feet would be pointing down slope and you would be facing north. And you can also use a compass direction off of a compass. And so we may ask you just maybe conceptually what is slope aspect, or we may actually give you a compass or give you some directions and ask you which what is the slope aspect, which direction is it facing. And aspect and gradient, they're really important concepts we want everybody to understand, because for example, some sites, some uses of the soil are it's more critical to have a level area. It's everything from development to farming. It's just easier to maintain, manage, and use your property if the slope is gentler. A steeper slope is more limiting, so it's important to know how to measure the slope, how to understand it and interpret it, either off of a topo map or on site, but also to know that maybe in some strange way, some things, maybe timber production, maybe some slopes need to be steeper for the promotion of timber production. Certain trees like a certain slope. And that also goes with aspect. North-facing slopes in the northern hemisphere, north-facing slopes tend to be cooler and wetter, and south-facing slopes, which get a little bit more direct sunlight, can sometimes be drier and warmer. So we actually work with some orchards and vineyards, and slope aspect is really critical. They, depending on what variety of tree or grape species they're growing, they have to work with the aspect and the slope gradient sometimes to maximize their production, to get good vigor and growth. So we may ask some questions about the shape of slopes too, the complexity of them, or the shape of slopes, and this information is also provided, or if it's not in the online study guide, it will be provided to you to help you interpret what the slope actually, how to describe it, what the terms mean. And the reason we look at this too is that, again, it's a use and management thing for the site, but slope shape is actually really interesting because depending on whether or not the site, as the slope goes down, whether it's concave or convex, actually determines water movement. So it kind of relates back to maybe some things that the aquatic station would talk about, as far as interpreting a watershed. If you want a sort of an area where water is sort of collecting and concentrating, you would want a concave slope. If you want water to shed away and have a drier spot on a slope, you would want a convex. So some of this is just learning the terminology, and why do I have to do this? It's just like looking at soil properties to better understand site characteristics for the use and management of a particular site for particular things. And gosh, I guess that's all I have. Those are mainly the topics, the subjects we would go through. The hands-on section is just like the written. There's not a set number of questions. There's just however many we feel we need to ask. I think the hands-on usually has fewer questions than the written. Again, they're multiple choice. Read the questions carefully. With the hands-on, you want to make sure the question you're answering, is it for the soils pit? Is it for the displays? Is it for something related to the site that maybe the proctor has to point out? I think the biggest thing, just having done the Envirothon all these years, this is a lot of stuff to learn. You know, everybody has presented a lot here today. Just I don't know. I had a boss once who helped with the Envirothon, and he was joking with the kids, and he said the most important thing to do today is to have fun. He goes, anyone who's caught not having fun gets 5 points deducted off their task. So I won't do that, but just try to remember it gets very serious, it gets very intense, but try to not let it overwhelm you. You know, try to have a good time, enjoy the experience. You know, it's a pretty cool event. So I always like to leave with a quote. One of the folks I worked with once said she reminded me of I reminded her of Henry David Thoreau because I guess I talk a lot. So, but I like this quote: "Shall I not have intelligence with the earth? Am I not partly leaves and vegetable mold myself?" So I just thought that was pretty neat. Anyway, that's all I have for the soil station.
Thank you, Fred. That was fantastic. And I don't think of you as vegetable mold yourself. And I think we've had a really good idea of what everyone can expect that day at the different stations. And I want to thank all the advisors, all the students, all the presenters today, all the volunteers who've done such a great job. And we're all excited about the in-person event on May 20th. And we've talked a lot about climate and weather today. And I want everyone to, you know, picture good weather for May 20th, because that can help us to have fun, as Fred suggested. So reach out to me and I'll direct you to the proper place if you have questions following this meeting. And thank you for attending the virtual workshop. And we will see you on May 20th.